this is question 43 of civil engineering paper of GATE 2016 afternoon session. Water flows from P to Q through two soil samples, soil 1 and soil 2, having cross-sectional area of 80 cm square as shown in the figure. Over a period of 15 minutes, 200 ml of water was observed to pass through any cross section. The flow conditions can be assumed to be steady state. If the coefficient of permeability of soil 1 is 0.02 millimeter per second, the coefficient of permeability of soil 2 would be. So here in this question it is saying that the water is flowing from P to Q through two soil samples. Here in this figure it can be seen that there are two soil samples, soil 1 and soil 2, and the water is flowing from point P to Q. The head available at point P is 600 mm and head available at point Q is 300 mm. So obviously due to this head difference that water will flow from P to Q. It is saying that over a period of 15 minutes, 200 ml of water was observed to pass through any cross section. That is, we can say the discharge is 200 ml in 15 minutes and the flow condition is assumed to be steady state. The permeability of soil 1 is given as 0.02 millimeter per second. Now we need to compute the coefficient of permeability of soil 2. So this question is from the topic of permeability of soil. You may study about this permeability and how to compute the permeability for stratified soils and laws behind this permeability. You may study all these things in lecture 9, permeability and seepage, soil mechanics geotechnical engineering 1 by Professor Dilip Kumar Vaid, IIT Kharagpur. Now coming to this question, we are seeing that the flow is the water is flowing from point P to Q through two soil samples. So we can apply the Darcy's law here. So the Darcy's law is Darcy's law for flow through soil is what? Darcy's law states that Q is equal to K I A, where Q is the discharge per unit time, K is the coefficient of permeability of the soil, I is the hydraulic gradient due to which the water is flowing, A is the cross sectional of the soil sample through which the water is flowing. Now here we can see that there is two soil samples, soil 1 and soil 2. So here we have to take this K as K equivalent. So now here the Q, the discharge Q is how much? In the question it is saying that is 200 ml in 15 minutes. So it is given 200 ml in 15 minutes. Now in this question we have to answer the coefficient of permeability in millimeter per second. So it's better to convert all the units in millimeter per second. So here we can write this 200 ml as 200 into 10 to the power 3 divided by 15 into 60. So the unit will be millimeter cube per second. So this is the Q discharge. Now I is the hydraulic gradient, which is equal to del H, that is head difference, divided by the length of the soil sample. So here del H, that is head difference, is 600 minus 300. 600 minus 300 divided by the length of the soil sample. So this is 150 plus 150. 150 plus 150. So it will be 600 minus 300, that is 300, divided by 150 plus 150, that is 300. So the hydraulic gradient, that is I, comes here as 1. So there will be no unit, this I is unitless. Now a cross sectional area of the soil sample is given in the question as 80 centimeter square. So we can write it as 80 into 10 to the power 2 millimeter square. Now computing all this data in this equation, we will get this Q as 200 into 10 to the power 3 divided by 15 into 60 is equal to K equivalent into I, that is I we got 1, into A, that is cross sectional area here, 80 into 10 to the power 2. Now if we solve this, we will get this K equivalent is equal to 0.0278 millimeter per second. Now this permeability is the equivalent permeability for both the soil 1 and soil 2. Now the permeability of soil 1 is given, and we need to compute the permeability for soil 2. So here we can see that the flow is normal to this bedding plane of this soil 1 and soil 2. So we can apply the formula for equivalent permeability for a stratified soil when the flow is perpendicular to this soil bed. So for flow normal to the bedding plane, normal to the bedding plane of the soil, we can write this K equivalent is equal to summation H divided by summation H by K, where H is the thickness of each layer and K is the permeability of that layer. So here in this figure we can write this, we just got K equivalent as 0.0278. Now here are there are two soil layers, soil 1 and soil 2, and the thickness is 150 each. So we can write this H1 plus H2. So this will be 150 plus 150 divided by H by K. So H1 by K1, H1 is 150, and the permeability for soil 1. So the permeability for soil 1 is given here 0.02 plus 150, since the thickness of this soil 2 is 150 mm, divided by K2, that is coefficient of permeability for soil 2. Now if we solve this equation, we will get K2 as 0.046 millimeter per second. So we got the coefficient of permeability for soil 2 as 0.046. So here we can write the coefficient of permeability of soil 2 would be 0.046 millimeter per second. So 0.046 is the correct answer for this question. Thank you.